up at the board here in just a second. So I thought I'd just review this with you. The way that you simplify, or one of the ways that you can simplify a radical, bless you, is right here. So let's say that we start off with the square root of 48. And the instructions are to simplify that to lowest terms. So square root of 48, simplify it. One of the ways to do this, the ways that I'm going to teach you guys to do this, is to break that 48 down into its prime factors using a little factor tree. So when we think about 48, 12 and 4, okay, I agree with that. So 12 times 4 is 48, but neither of those numbers is prime. And so we want to keep breaking it down. What about the 4? What does that break down to be? 2 times 2. That's right. So those 2's, those are prime. What about the 12? You do 2 and 6, or you could do 3 times 4. Either way. I'll do 3 times 4 since you said that first. Of course, 3 is prime, but as we know from before, 4 is not. 4 is really 2 times 2. So your prime factors would be 3, 2 times 2, and 2 times 2. We've done that a bunch. Now here's what we would do with this as far as square roots go. I would take my prime factors. It would be 2 times 2 times 2 times 2 times 3. Can I show you guys one little notational thing that you may or may not have ever seen before? I'm going to take my square root and I'm just going to put a little cap on the end of it. That tells me that ends the square root. Sometimes the square root gets a little bit too short or a little bit too long and it gets confusing as to what is actually inside the square root. If you cap it off right there, it tells me, okay, that's the end. Anything to the left of that little tail is going to be inside the radical. Okay, so then as far as simplifying this goes, we're looking for groups of 2. And so I've got 2 2's right there. I've got another pair of 2's right there. The 3 does not have a 3 to pair with. So, Rocky, you listening? Y'all with me? You good?
Yeah.
Okay, I just want to make sure. Are you writing with me or no?
Yeah, I was going to start writing. I was just wondering when you were writing.
Okay. I was just using that practice at the board spot. Okay, so I've got 2 2's. That means those 2 2's get to come out, but as they come out as only 1 2 because they're being square rooted. This pair of 2's gets to come out as well, but they only get to come out as 1 2 because they're being square rooted. So this would be 2 times 2 times the square root of 3. Of course, you could rewrite that if you wanted to as 4 times the square root of 3. Okay, there is another way to do these, but that is a good way, at least, for us to do those. Okay, so let's go ahead and head up to the board and see how you guys are doing with those. That next section, the little heading on there says that these square root expressions that we've been working with, they can also have variables in them. And so the good news is these will behave exactly the same way as what you guys just showed to be pretty good at. So if you take a look at example like, say, number 3, number 3 is the square root of x to the 5th. What's nice about these is finding the prime factors of x to the 5th is a whole lot easier than doing all those factor trees and factor ladders. Here's all you really got to do for x to the 5th. We'd say square root of x times x times x times x times one more x. That's what x to the 5th is, and it's prime factors. So once again, just like the numbers with the variables, we're going to look for pairs, right? Pairs of groups of 2, if you will. So there is a group of 2. There is another group of 2. So as this pair of x's gets to come out, it's only going to come out as a single x. And this pair of x's gets to come out, but it'll only come out as a single x. So this would simplify to be x times x, square root of x, or you could write it as x squared, square root of x. Yes, sir?
Why can't it just be x to the power of 2 half?
Yeah, so you've learned about the rational exponent stuff? Or you're thinking about like it's always half?
Yeah.
Yeah, so that's actually would be a thing, right? That'd be something we'll look at coming up pretty soon. But for now, we want to leave the radical in there as is. And so this would just be a different way of simplifying it. But Rocky, your thought is a good one, and we will do that. I'd want you just to be good at both, I guess, would be the way to put that. Okay, let's take a look at number 4. Number 4, of course, is 4 times the square root of root 27m. So to be consistent, just like you guys did at the board just a second ago, we're going to take anything inside the radical and break it down into its prime factors. So 27, by any chance, does anybody know what 27 is in prime factors? Yeah, it's 3 cubed, isn't it? So maybe you do a factor ladder to do that, a factor tree or whatever. Either way, we want to get to that place where we have that 27 broken down. So this would be 4 times the square root of 3 times 3 times 3 times m. So when these numbers and letters start trying to pair up to get out of the radical, how many groups of 2 do you see pairing up? Just one, right? It would just be the 2 3s. So there'd be a pair of 3s right there. It looks to me like the last 3 in the m don't have anyone to pair up with, and so they're going to have to stay in the radical. And so that pair of 3s gets to come out here, comes out as a single 3. 3 times 4 times the square root of 3m. For a final there. Does that make sense to you guys? You guys really showed you're doing good with this. So let's just do one more, and we'll go back up to the board, see how you handle all these variable expressions. How about number 5? Number 5. So this has a fraction in it. I don't know if that makes too much of a difference to you. Bottom line is you've got a radical with 72 x to the 5th. And so we're going to break that down into its prime factors. Has anybody started ahead on this one? What would the 72 break down to be, Jake?
2 times 2 times 2 times 3 times 3.
I agree. So 2 times 2 times 2 times 3 times 3. And then all those x's, there'd be 5 of them, right? So it'd be times x times x times x, and then 2 more of them. So unlike number 4, where there was only one pair of 3s that had a chance to come out, there's going to be a lot of pairs of things that can come out here. So did you guys notice that there's a pair of 2s? What else is there a pair of?
3.
A pair of 3s.
And 2 pairs of x.
2 pairs of x's, right. You guys got it. So those are all factors that can come out and be square rooted. So this is going to be a 2 out, a 3 out, and then an x, and then another x. So I'm going to have 2 times 3 times x times 1/6. What had to stay inside the radical? Not everybody got out. Not a 3x.
Oh, 2x.
A 2x, yeah. So this 2 right here did not get to come out. This x did not get to come out because they didn't have anybody to pair with. So those would be left inside. Did you guys notice how nicely designed this question was?
6 and 1/6.
Yeah, 2 times 3 is 6. Wouldn't that cancel out to be a 1 with the 1/6? So you'd end up with x squared root 2x. So I realize that there's x's and m's and other variables in these, but do you see the connection between what you did earlier and this? It's the same thing, just with variables or numbers or both. I hope you see that. So let's head up to the board and we will try some more of these in practice. Yeah, sure, that's fine. I don't know this section. So again, a reminder to you, tonight, this afternoon, sometime soon, really think seriously about working on your web assign at 8.1 and 8.2, because tomorrow you can come in here and ask questions and hopefully get answers that will help you as you prepare for your quiz next Monday. So here we go. We're going to be using what's called the quotient rule for square roots. And here's what it is. It's essentially this. If you have the square root of a fraction, like this over here, if you have a square root of a fraction, then that is the same thing as the fraction of 2 different square roots. In other words, you can break that radical up to be the square root of the numerator over the square root of the denominator, and oftentimes this will be a help. This rule goes both ways too. If you have the square root of a over the square root of b, you could simplify it going from right to left and make it just one big square root. But today, we're mostly going to be focusing on going from left to right, where we go big square root equals a little square root over a little square root. So an example of how this could work, number 6, simplify completely. Here is one way we could do this. I could say that square root of 108 25ths could be rewritten as the square root of 108 over the square root of 25. So the square root of a fraction could be rewritten as a fraction of two different square roots. So one thing we could say right away, do you guys know the square root of 25?
Yeah, 5.
5, okay, so that's kind of nice. That was a pretty quick one to do. Square root of 28 might take a little more effort, right, Christiana?
Can I do it?
Sure.
Okay, so first you split up to 9 and 12.
So 108 goes to 9 times 12, okay.
Yeah. Then 3, 3, 3, 4, and then 4, 2, 2.
And then the 4 becomes 2 times 2.
And then so you have a pair of 3s and a pair of 2s, and 1 3 left over. So then it's 6 radical 3.
Christiana did a pretty nice job explaining that. So this would end up being 6 root 3, or 6 times the square root of 3 divided by 5. What do you think?
Good.
Christiana, thank you. Good job. Good job. Okay, so let's take it up a little bit of a level here. Let's take a look at number 7. With number 7, you can see that there are now some variables involved. There we go. So one thing I want to bring out to you, there's a number of ways you could handle this. I would encourage you to think about this. Before you get too wrapped up with square roots and pairs of this and pairs of that, always look at the fraction on the inside of the radical and ask yourself, before I do any factor trees or factor ladders, is there anything about that fraction that I could simplify right now?
Yeah, the x's.
The x's. Do you see how there's an x cubed in the top and an x to the first in the bottom? Couldn't we just subtract our exponents? So I think I would rewrite this before I did anything else as 44x squared over 81.
Wait, can you just leave it though?
Can't we just leave what?
Can we just leave it?
Just like leave it as the original?
Yeah.
You totally could. To me though, this feels easier because if you don't do it this way,
I just already did it.
you're going to end up with like root x's. See, you can simplify that. That's not going to be simplified completely. That's not right. You can go further than that. So that's, in the interest of simplifying completely,
Okay.
I think that it's easier to do it that way first, because then you don't end up with like these root x's that you need to still cancel out.
Now you cancel out the root x's.
I just think it's easier to do it on the front end. If you disagree,
so
you
then you minus that over that, and it's just
Yeah.
2.
yeah.
Wouldn't it be 3 and 3?
So, hey guys, hey.
Yeah, sorry.
So square root of a fraction could be rewritten as the fraction of 2 square roots. So it'd be the square root of 44x squared divided by the square root of 81.
11 and 4.
Well, square root of 81, that's a perfect square, right?
Yeah.
So 9.
Top one.
And then the top one, yeah. So
2, 11, and x is x.
44 is 2 times 2 times 11 times x. I agree with you.
Which is 2x root 11.
I've got a pair of 2's and a pair of x's, right? So this could be rewritten as 2x root 11 all over 9, and that would be simplified.
Can you simplify it more to make it 2x over 9 root 11 over 1?
I don't know that that's any more
Wait, I have a
simplified.
question.
I'm still talking. I don't know that that's any more simplified, but you certainly could do that.
Okay.
Essentially what you're doing is
It both makes sense.
you put it into two different fractions multiplied together, and I don't think yours is right or wrong
Okay.
compared to this. I think it's really the same thing. So I could go either way. Your question.
Can it become 3?
Can what become 3?
9?
Why would it become 3?
Because that's a square root? Or
Well-
just kidding. Done.
We only had to do the square root once. If I square rooted the 9, wouldn't I be doing the square root again?
Yep.
And I'm only instructed to do it once.
I didn't mean the question.
Okay. Okay. All right. So we got to. Oh, I'm sorry, Jake. Go ahead.
We've already used it.
If you didn't subtract the x from the top and bottom,
Yeah, at the start.
would another correct answer be 2x radical 11x over 9x, or 9 radical x?
Like that? So that's not numerically wrong. There is a problem with it though, Jake. The problem with it is you have not simplified completely. Completely. So the truth is there would be another cancellation to be done here. It'd be 2x root 11 times root x all over 9 root x. Those root x's could cancel out. So it just tells me that there'd be one more step to go as far as simplifying it. And so for that reason, I would say simplifying on the front end eliminates the need to think about that. So I would suggest we try that instead. Okay, so we've got a couple minutes here. I think we can get a couple more rounds in. And I don't know if anybody can catch the llamas, but I think we should try. So head